Hey everybody, it's Taki117 here, back with Taki Space Program. Here we have our lunar altimetry satellite on its way to the moon, and we are about 20 minutes from our maneuver node. So, we're going to go ahead and warp there, and then we are going to perform that burn and perform some other missions. Oh. Whoops. So the good thing about being in deep space and maneuver nodes and whatnot is that you can pass them and it's not a big deal. So here we are, we're just going to perform this maneuver. It's going to be a little off, but we still hit our target. So just bringing my periapsis down. Yeah, that's good enough. So we are once again going to point normal positive to get as much power as we can on these solar panels. But while we wait for this, let me check my alarms here. Yep. So while we wait for this to enter the moon's sphere of influence, we are going to perform another couple of missions. So we're going to head back to the Space Center and finish building our Venera 1 rocket, as well as OSO-1. As soon as we get done loading here. Now, I am still running version 1.13. Mostly because all of the mods that I'm using work with it. So, Venera 1 was the first... Ooh, that was fast. Anyway, it was the first satellite sent to another planet. It was sent specifically to Venus. Now, that's going to be a little difficult because I don't know the exact transfer window between, Kerbal Earth and Kerbal Venus. So it might be sitting in storage for a while. We are inside the sphere of influence of the moon. Awesome. This is good. And we still have our connection. So I guess we're not going to be doing that mission just yet. I do want to point radially in... Actually, no. I want to bring up my maneuver planner, because I want to change my inclination to a polar orbit after... we'll go 60 seconds. So we are going to execute that node. Now the reason I'm doing it this way is because I'm fairly close to the edge of the sphere of influence of the moon, which is the best place to perform plane changes. If I tried doing it, elsewhere, like closer in, it would actually cost me more delta V to try and perform this maneuver than it does just by simply performing it way out here. Yeah, there we go. Now it is going to push us once again onto a hyperbolic orbit, but that's okay. This one, I want to change my periapsis at the next periapsis, and I want it to be, we'll go 35 kilometers. Now, the reason for this is because, for some reason, the maximum altitude of the scanner has been changed to 47 kilometers. Now, obviously, around Earth, I can't orbit at 47 kilometers. The minimum altitude that I can orbit is about 100 kilometers. I believe it's actually 70. I'll have to check it. But anyway, the point is, I can't get to a 47 kilometer orbit. But the moon, because it does not have an atmosphere, I can. So we're going to come down to a 35 kilometer periapsis, and then we're just going to circularize there. And I still have plenty of fuel. But I think what I'm going to do is I'm actually just going to overshoot this a little bit. And then bring it back up. So we'll go ahead and let the autopilot take care of this initial maneuver. There it goes. Performing that correction. It's an orbital insertion, if you will. Now, the main reason I'm doing this is because, well, I have all this extra fuel up here. I don't need this transfer stage anymore. So I'm going to drop my periapsis. Then I'm going to, there we go. Now I'm going to use my RCS thrusters, because these do have RCS thrusters, to translate out of the way. Really what I should have done is probably ditch that normal instead of... Oop. Don't need RCS there. There we go. Alright, so now we are clear of my debris. And we're going to bring our periapsis back to 35 kilometers. There we go. And now we simply circularize at periapsis. And where is... See, this is why I like doing these things in map mode, because I can always find, or I can always see the moon. Oh, that is a beautiful picture right there. Got the Earth, and then you got the moon, and this little satellite flying overhead. Here we go. Get ready to fire up this tiny, tiny little engine one more time. Here we go. In 3, 2, 1, and beautiful. Burning the liquid fuel and oxidizer that is on board the spacecraft. Putting it into an orbit of the moon. That is... Ooh, there's Mercury over there. And we got... What is that? Is that anything? That is something. Mars. I always like looking at, these bright specks and seeing what they are, like Jupiter and Uranus. Okay, so we are successfully in a 35-kilometer orbit of the moon. Well, we just passed over the North Pole there. So I'm going to point radial out. Is that the way I want to go? Not quite. I want to point retrograde. Now, with a roll of 0 degrees instead of 90 degrees, so that my sensor points down. Now, you don't have to do this. This is just something I do. See, scans at altitude ideal. And it will now begin scanning the surface of the moon. There we go. We are just going to let it do its thing. Now we're going to go back to the Space Center and finish building our Venera 1 and our OSO 1. Anyway, Venera 1 was a Soviet rocket that was sent to Venus, and I believe it was the first of its kind. It was the first artificial satellite to leave the sphere of influence of the Earth with a destination in mind. You can remember earlier we did the Luna 1 mission, which of course left the sphere of influence of the Earth, but it didn't have a destination. It's just kind of floating out there in the sun, floating around the sun. So we're going to it's an old warning, right, because we put into a low orbit. We're just going to finish building this. And it's probably going to sit in storage for a while. I need to figure out... I do, however, want to build OSO 1 and launch it, because all it's doing is going into a 500-kilometer orbit and transmitting science from space around the Earth. Oh, and my low-resolution scan has completed successfully. That's good. I'm up to 92 science. I don't think I can... Nope, I need 160 to get more things. Looks like more fuel tanks. Tiny things. Ooh, these look fun. Tiny engines. Tiny stuff. And fuel cells, radiators, better communication dishes. I might actually get this one next. Get that so I can do some things. Alright, so we have successfully completed both of our rockets. So I'm just going to roll OSO 1 out. Now, because this particular launch is not time dependent, I'm not going to worry about it. Close the alarm. We are currently on the pad, so I'm just going to warp to the next morning. There we go. And this satellite is going to stay in orbit for a while. I completely plan on using this satellite for as long as I possibly can, along with all my other satellites. In fact, you'll see as we progress later in story mode, or later in career mode rather, it's not necessarily story mode, that I'll be reusing these designs because, well, they work. And I do not yet have ascent guidance. So, here we go. Launching in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. ignition and liftoff. We have cleared the tower. So once again, rolling to 0. Not a crucial step, but it makes me feel better. And this is going to be in a relatively equatorial orbit. Go down 10 degrees. And now we're just going to point surface positive and let the rocket do the work. I do want to increase... no, other way. My pitch, so that it will continue falling. There we go. Our delta V, our maneuver planner. A little bit of cloud cover over the Kennedy Space Center at the moment. That's okay, it does not affect our rocket launch at all. We are climbing steadily, pushing that apoapsis up to the 500 kilometers that we need. And the satellite's just going to sit there. You know, it doesn't need to do anything. I do have scientific instruments on board. And start pitching down some more, just ever so slightly, pulling that prograde marker along with us. Now, up until this point, all of our rockets have been two-stage, and in fact this one is a two-stage rocket as well. But our Venera rocket that we finished is actually a three-stage rocket. And the reason for that is so that we have tons of fuel left over. Alright, so separate that. There we go. Now, the reason our Venera rocket is a three-stage rocket is so that we have enough fuel and enough delta V to get to Venus. Now, we don't have to orbit Venus, but we have to get there. So you'll notice when we roll it out to the pad, it looks a little bit different than our standard rocket. Alright, we're in space. I'm going to go ahead and ditch the fairing. And this has a bunch of different science instruments on it. The main reason for that is we haven't done a whole lot of science in space. A bunch of different science instruments. Go ahead and activate that. This is OSO1, isn't it? Oh dear. Yes. Okay. So yeah, the main reason for all the science instruments is we haven't done a whole lot of them in space. So I figured I'm going to put everything I have on this. Ooh, wow. I got a little overzealous there. Went to, I'm going to go to 600. You know what? Screw it. I can adjust later. So I'm going to change. My periapsis is 500 kilometers. Apoapsis is going to be 500 kilometers. And let's see, we'll try 10 minutes. Create node. Okay, well, that's good. So now I'm trying to figure out exactly where my rocket is going to be Okay, so I need 5 minutes, 45 seconds. $46. We'll go 40 seconds. There we go. 5.5. Ooh, now we're getting somewhere. 25. So basically what's happening is, you know, I'm going along my orbit. Instead of trying to figure out where, you know, I'm going to be, I'm just going to continue to update there we go. So we are going to execute that node. I am going to go ahead and activate that and point it at Earth. Just in case, well, actually, I want to point it at the moon, I think. Yes, I'm going to point it at the moon. That way, it will definitely cover a target. And I will have communication. Oh, wow. I'm pointing at a lot of things. I mean, it doesn't cover any targets, but oh well. We are still connected via this antenna here, which now has a range of 2 megameters. All the fun little science instruments on here. There we go. So this orbit's going to be a little lopsided. I'm okay with that. I'm bringing my apoapsis down while simultaneously shifting my periapsis up. Eventually I'll get to the point where I'm running more prograde than I am radial. Maybe. See, this is why I let the flight computer handle all this. Is because, you know, it's tedious, it's kind of a pain in the butt, and it can fly a lot better than I can. Periapsis of 500 kilometers. There we go. Alright, so we are going to point prograde at a bunch of different satellites here. And now I'm going to do all the science. Like that one we've already done. This one we haven't done, so we get 18 science from that. I'm going to record this, we get, you know, 2.7 science. Record that, get another 2.7 science. Let's adjust. Here we go. There we go. Let's get some more electric charge going there. Log pressure data and transmit that. Let's do some telemetry. I don't need to do that. That's good. Let's do a crew report. Some science off of that. Oh, I did set up a... That's good. set up. So basically what I did was I set up all of my science instruments on one action group. So when I hit the G key for gear to toggle my gear, it activates all of my science experiments all at once. Now I don't have enough electric charge, so what I'm going to do is I'm going to warp a little bit. Because I am generating plenty of electric charge, it's just, you know, not enough of it to transmit science. So we're going to sit back and we're going to watch this for a minute. Just orbit the Earth. Hopefully my batteries last. Just moving over there. Okay, I think we are done collecting science. So I'm going to point retrograde. And go ahead and drop this stage here. So remember, everything that goes up must come down. I'm gonna point radially. Off it goes. Spinning away before I point prograde. See, now I'm already clear of it. I don't have to worry about debris. Actually, I'm going to change my periapsis to 500 kilometers. Oh crap, abort. Crap. 500 kilometers, let's... Oh, well, I'm still in orbit, so it's not actually a big deal. So yeah, we're gonna do that. Bring our apparatus down to 500 kilometers. Oh dear. This does not have enough battery life. That is unfortunate. So I will be losing communication on the dark side of the planet. At least with this satellite. Not a big deal. Like I said, maneuvers, you can overshoot them by a little bit. Now obviously if you're 7 to 10 minutes away, you know, it's gonna screw things up. But if you're a couple minutes, or in this case half in orbit, as I try my best, there we go. So go ahead and execute that. See, and again, it's still going to perform that maneuver. I'm going to change my periapsis at the next apoapsis. I'm going to create and execute. And that should be on the day side of the planet, yes. Oh, right over there. Beautiful view of the Earth. I love that Earth. It's a nice place to live, isn't it? So anyway, we are going to put this into a circular 500-kilometer orbit. Maybe. Oh, we're still a few seconds away from our burn. 12 seconds. There we go. So, that's all for this episode. Until next time, I'm Taki117, and remember, it's only rocket science.